talk about. So you can feel free to have a look, fork it if you want to try it out. So first of all, who am I? I'm one of the senior developers at Funding Circle, a company in London. So if you're interested in Clojure, CLOJURESCRIPT, let me know. Come with me. I worked with APIs and Python for a long time, and I was happy. But then I was doing some front end as well, some time to time with things like Knockout.js, Angular, or some other horrible things. Then eventually, so I never actually liked the front end. So eventually, a couple of years ago, started to use Clojure, and I finally saw the light. And that also actually made me quite more interested again in front end. And now, as you can see, it's much more fun than it used to be. So the outline of the talk, I'm first going to explain about the ELO algorithm, which I think maybe here near Russia, more people know because it's kind of related to chess. I think the guy who invented it was actually Russian. And then I got to do introduction of Reframe and reagent, which is the frameworks I've been using in the libraries. And then I will do a demo of the actual project to show you how these all go together. So first of all, I think, how many people here know Clojure or can, yeah, good. Quite a lot. Reframe as well, yeah, nice. Okay, cool. So I will still have to introduce quite a few things, but so first of all, I think why did I do this project, which is kind of a platform to be able to rank players in a league. So you have a few players, you are with some friends, and then you play some game, which can be anything, and then it gives you some sort of ranking, say who's better. Because I think in every office that I've been to, there was some sort of internal leagues, and then you see in every kind of reasonable startup, you have some games, and it's quite fun if you make it more competitive. At the same time, you also need some technology, otherwise it wouldn't be as fun. And then I've seen all sorts of solutions, even like Excel spreadsheets, or and they all work. But of course, it's more fun to make another one. So that's kind of the idea. The ELO algorithm is what is the central point of this tool, this platform, and it comes from chess. Arpad ELO invented it, and it's quite an interesting algorithm. It's quite simple but very powerful at the same time. So it's a method for calculating a relative skill levels of players. Relative is an important bit because it means that if you have your own league of 5 people and you always win, you can get like a high ranking, but it doesn't mean anything outside of your league. So you can still be beaten easily by someone else from another league. So in chess, for example, there is kind of a global league in a way. So like they had the greatest players in chess, they play against the whole world in theory. So the system, that's why kind of it's more an absolute level at that point. But if you have your own leagues separate from each other, then each one is different. It can be applied to any zero-sum game, where zero-sum game means that one person wins and the other loses, or maybe they both draw. But it doesn't work with games which normally are, I don't know, psychological names, where if you do certain things, you both lose. If you do another thing, you both win. But any other game, which is one player against the other, and one wins, is fine. And also the important thing is that if you want to compute new rankings after a game, the only thing you need is the current rankings and the result. So nothing else. You don't need the whole history, you don't need to do any fancy thing. That's why it's quite fast and easy to implement. And the other important bit is that the average of the rankings is constant. So everyone starts from 1,500, like the default value, and then so one player wins, the other loses. So one player gains X points and the other player loses X point. And if this happens all the time, it means that the average will always be the same. Because if that wasn't true, eventually all the points will go to 0 or to infinity. But thanks to this property, it never happens. So all right, I'll go to the actual project 1 second to show you how it looks like. Well, can't really see very well. But so here you have a list of players with some rankings, and here it says that Frank is like in the first position with 1-5, some 5. There's a number of games. So the number of games actually is kind of important to notice. Is not everyone does the same number of games. So it's not like a league in football, which where a team wins 3 points if they win, but that works because everyone does the same number of games. If you don't have that property, then of course you need this kind of algorithm. Then you see the form factor here, like win, loss, win, loss, and then some other statistics. And then the nice thing is that there is a graph which shows like the ranking going up and down for each player. And you can also go back in history, which is quite nice. You can go back in history, everything kind of updates automatically, the rankings here, the form factor, the number of games. And that's how the platform works really. If I want to add a new game, I just go here, I'll do it later for the next demo. You just go here, add game, and then everything updates automatically. So if I just want to show you, well, what actually means from the beginning, if I now start, everyone has 1,500. After the first game, you see only 2 dots, and John now has 1,516, and Emily is 1,484. So the difference, since they both start from the same level, they both gain or lose the same amount of points. If one player is much better than the other, then that changes. So now again, just 16, 16. But here already you can see that this change is 14 and not 16 anymore. So in the graph, you can already see that things are starting to go. And then whenever I do something, it will always be kind of symmetric. So one player goes up and the other player goes down by the same amount. That's more or less how intuitively the algorithm works. So let's see the actual formula. No, don't be scared, there's not too much maths, I think. So we start from both 1,500. Then we have something called the expectancy, the expected value from player A. And this is the formula you use to calculate it. In this case, it's kind of trivial because RB minus RA is 0. So you get basically 1 divided by 2, which is half. And the same for AB. If that wasn't true, here you would get like A would be bigger than EB. So then the second part of the formula is that you actually have to compute the new ranking from the previous ranking, and then a K factor, and then this expected value here. And what happens is eventually you get 1,516. And same for the other guys. So here you add 16, here you remove 16. So that's how the formula works. So it's kind of easy to understand. And the implementation, it's even easier maybe than actually the actual formula maybe. So the expected here in Clojure is just divide 1 by the increment of this power here. And the new rating is just take the old value, then multiply K by this thing. I can actually show you very quickly this. What is it? Algorithm. If I now do new rating, and then 1,500, then I do expected minus like that, and then I pass the score. So this means, no, I made a mistake, of course. Not expected. Yes, shared. Okay, so here I get just the same. One second, what was the example in the actual, okay, because I had it here. I just did it before, I forgot. That's the old value, then you got expected. Right, yes, that's why. Yeah, okay, better. You see now if the other guy, for example, was much better, and the 1 means I actually won here. Here I get 20 points instead of 16. So eventually, the K factor, which I was showing before, limits to the maximum number you can grow or lose. So, for example, if the other guy is really much better, it's like 3,000, then you gain 31.99 points. So eventually, to infinity, it will converge to 32, the number of points you can. It will kind of grow logarithmically in one way, and then get to 32 to infinity to some. And this K is something that you can adjust depending on the things, the league you're doing. So it's not always the same. So in some chess leagues, maybe they want a lower one or a larger one, depending on the things. So the bigger K means that if you lose against someone that is really bad, like you lose a lot of points. So like good players maybe don't like it that much because maybe they have a bad day. They lose against this guy who never played before. So yeah, that's a very simple, how do you call it? So let's go back to the slides. The rest, the second part of the implementation is a function that actually, given some rankings as a map, returns you the new rankings computed. So you need then to do that, you need a way to declare how a game result might look like. So you have player 1, player 2, and then 0, which means that player 1 lost in this case. Let's show just one possible representation. So you pass this ranking, the existing rankings, and then you pass the result, and then you get the new map. So the implementation is quite straightforward. It's simply it's kind of symmetric. So the first P1 gets the value in the same way, and then we also have to do this invert score here because. So if you draw, you get both the 0, 5. If you win, the other person you have 1, and the other person is 0, and so on. Okay. So why just Clojure and Reframe? I think this slide, I didn't have this slide when I showed this in a Clojure meetup, but maybe here is actually useful. Well, functional programming, which is everyone I think likes here. Immutable data structures, which I really love. I think one of the things that was annoying me more in Python was not kind of the lack of types or anything, but it was actually mutability everywhere, and that really helps. It's a Lisp. I think people love it or hate it, but that's already a great reason. And then important thing when you're doing a project which is full stack, like the one I'm presenting, where we have Clojure on the backend, CLOJURESCRIPT on the front end, is that you really can do everything with the same language and everything data-driven as well, which is something I'm going to show in a bit. So you have, we have CLOJURESCRIPT, which is actually then transformed to JavaScript, but there is also Garden, which is something to generate CSS from Clojure data structure. So again, you still have Clojure, and you just have data, and then you transform it to something else, which is CSS. And then a very important thing is to get immediate feedback for anything. So you already have the REPL in Clojure, which is great, and then you can try out things, and you never have to restart. It's quite fast. But with the front end in place as well, you really get immediate feedback whenever you change something. I'm going to show you in a bit. If I change the backend, the front end, or the CSS, things just happen straight away. I don't have to do anything, which is great. And Reframe, the Reframe is also a great framework as well, and this functional reactive programming in the end. And that's the thing which really helps you write your application in a way that is easy to understand and you don't end up in a big mess. And the more even surprising thing in a way for me was that I could write like, I don't know, 95% pure functions and then do like a project which is a full project that actually does stuff. And it's even more easy to write pure function with Reframe and on the front end than on the back end, for example, because you don't even have things like the database or other things to talk about. You're just talking with some global state, which is handled by the framework itself. You don't have to worry. You just write pure function that transform data, and you get the result. And underneath, React will do the rendering. So what's Reframe? So Reframe is a framework, which is the on the actual website, they define it as a pattern for writing SPAs in CLOJURESCRIPT using reagent. It's a pattern, I guess, because it's quite small. In the total is 750 lines of code, which is surprisingly small. And it doesn't actually dictate really how you have to do things, but it does give you all the tools and the way to write your thing in a functional kind of reactive way. And then it's also important that, well, it's designed to be used for SPAs. You can also, however, write even bigger pages. So my project, for example, already has 3 separate pages, so which are then, you can have multiple reframe things, instances at the same time, or you can have the same one and then do routing on the front end. Or you can even do reframe server-side rendering that some people are doing, because it actually works also on the backend. So you can do anything you want. It's just quite so. And the building blocks here are React, which is really the JavaScript component in the which then eventually will render the DOM. And then I don't know if you're familiar with React, but so the main concept is that you don't have to worry too much about how things are rendered. You just have some data, and then React will know when that data changes that it needs to re-render a certain component on the page. So that's kind of done automatically for you. Reagent is one of the many layers, kind of wrappers around React that exist in the Clojure community. Others are things like RAM, I think Omnext are vaguely kind of the same. And Reagent is probably one that was more successful, easy to use, and quite nice. And Reframe, it kind of sits on top of that. It gives you the whole thing that you don't have, so how to handle the state. And it's similar to things like a Redux in JS world, from my understanding. All right, so just to give a very short introduction to the syntax. We have here some JSX, and here some reagent. So at the end of the day, the JSX, what I think I really find terrible is that they mix up HTML and code the same thing, which doesn't look good. And also the important thing is that this is not data. This is just like code in the end, even though it looks like there is some HTML here. The reagent equivalent here is actually just a vector. So you have a user, so then if you have the user, then return a vector with h1, and then you construct a string on the fly like this with normal standard Clojure function. And the other interesting thing here is that this, in theory, to actually call a function, you normally use a parenthesis. But here you have a square bracket. That's something that people get tripped up with, and that's because this is related to the kind of React underneath and the reagent. It means that these will eventually be called by reagent when something changes that it needs to re-render. And if you pass it as a function, if you do a function call, then it cannot do that. It will always be called. But if you pass it as data, then it knows, okay, so this is a function. Eventually, if something changes, I have to call it again. So that's quite important. So let's see Reframe in action. We've seen before the little project that we're showing, and in a way we can split the Reframe architecture into model view controller, which even though maybe it's a bit small, but it doesn't fit. It's not maybe the exact terminology, but you can say that the model is kind of a global database. Where by database is just really a map or a dictionary in another language. And this map is completely controlled by the reagent and reframe framework. So you have access to that, but you never change anything there. All you do is to create a function that returns a new one, and then eventually reframe will replace the existing one. or you create a subscription to get some data from it. So this thing is just kind of a global thing, which is considered to be your current state. And from this data, in theory, everything should come out of here. So the whole behavior of your SPA depends on this. So the controller, in a way, can be considered these subscriptions and the event DB functions. So here, as you can see, we have a function which takes a DB, which is the thing I was showing before, and I create a subscription colon game, which is a namespace keyword. You don't have to use namespace keyword, but it's just nicer to do. And then what all it's doing is to extract value from that DB. And someone else can subscribe in a view to this thing, and then when that value changes, then automatically that component re-renders. And the similar thing is reg event DB, and this is actually how you change data instead. So you dispatch, when you dispatch an event to PU1 using, you will call this function, and then which will get this value in, and then will associate to the DB something else. This is a way to put a value in a nested map in Clojure. So a sock in, you insert inside. So and that's it. You don't actually mutate anything at this point or at this point. Everything is just pure. So you can test it easily in theory just by trying out. Last thing is the actual view. So the view is the bit where you actually display your data, and this is this is the syntax to actually create some HTML. And this syntax is called hiccup style, and we use this syntax for a bit of everything. And the more kind of extraordinary thing I think is that we can use this syntax both on the front end and on the back end in exactly the same way. So whenever I did some projects and I wanted to move things from server-side rendering to client-side rendering, I didn't have like a Django template or some other different language for the template and then something else, JSX for the front end. I just exactly have the same data structure. I take the data structure, I move it, or the function, I move it to another file, and it works. So it's kind of incredible. So yeah, the subscription here. So here first you subscribe to something, and with the @ you already dereference it. So I already get the value as well. I don't just subscribe. And then I create an input form, an input actually text where I want to add the name of the player. And the value, you get the value from this map, which is actually a submap of this default database we're seeing. And then when something changes, there is this function which is just a helper for actually dispatching an event. So the dispatch event will take the value that is currently on the input box, send it to Reframe. Reframe will take care of updating the DB, and then other things might happen. The last thing is the API calls. So API calls are just a way, so you can do in different ways, but the very nice thing about Reframe is that you can actually define your own ways to have side effects, but not doing side effects yourself. So it's a bit convoluted, but so if you look at this thing, so what this reg event affects is taking as argument. It's taking a function which gets the database, and then it returns a map. So that's all it's doing. So this map is just a map with HTTP XREO and then some other stuff. And this HTTP XREO is kind of a special key that means that eventually when this thing gets dispatched, as a side effect, it has to do an HTTP call. So you don't have to write the HTTP call yourself, you just write it like this. And then what happens is that you have to define what happens when something succeeds or fails. So on success, for example, it means here on success, dispatch this other event, and this other event is actually what is going to write to the database the value that you want. So at this point, we're not writing anything, we're just like saying, okay, this is how you should do this thing, and then this is what you should do when it works. And here, you actually write it to the database. All right, one last, let's go to the demo first, and then I'll show you kind of one last thing. So just to quit this thing. Another very nice thing about Reframe is that you get this tool, which is kind of, Jesus, can't see anything. Something called Reframe 10x, which I don't know if I will be able to show much because it's a bit clear. Can you see something? So at any point, so if I change something in any of these input box, things will happen, and then it will update the database. And the database is what's being shown here on the right. And so I can see here, like it's very easy for debugging and things like that. That when I add something here to 1 or to 4, here is what I get. And these are all kind of sub-keys that I use in different parts of this page. So for example, the list of games is all here. A game has a P2 player, there's a league ID, it can be different leagues, P1, when it was played, the points, and when it was recorded. So this kind of, from this information, everything else can be kind of computed. Then another thing is that you can also see all the subscriptions, which is also quite important. One thing, for example, is that I'm not able to fill in this form to add the game until the form is fully filled up. So we have this subscription, like valid result and valid game, which until they're both not true, it won't let me actually do anything. So now that they're both true, then I can do things. For example, if I put the same player here, again, it's not valid anymore because it's not valid game. So that's how you can do validation. You can do like all sorts of things. You just define some subscriptions, and then you can see how things are working. So this is a great way for kind of looking into some other application and see how things are working inside. So suppose now I create a new game. So in this particular example, it's FIFA, but it can be anything else really. That was just one possibility. So suppose Charlie plays against Emily and wins 3 Barcelona. Then this, and then I add the game. So the results will be immediately kind of written up. I have to go to the last game here, and you can see, yeah, the game is recorded here, and then the things were updated. The graph was updated. Another nice thing we have are this little thing here. So there is a way to hide some players. I don't want to see this play, I don't want to see this play. If I do that, it doesn't actually change the result. It simply hides. But if I actually kill something, then everything changes, because if I kill that particular player, it's like his games never happen, and then the whole graph updates and all the rankings change as well. So if I want to do like a 1 vs 1, for example, I can just kill everyone and then see Emily 5th. How did it go? So I can say these are, and then it filters out just on their games. So actually, important thing which I didn't mention is that everything at the moment is completely done on the front end. So the only thing that the backend is doing is returning the list of games. And that's basically it. And the thing is that all the code that does all the computation, the algorithm and everything, is, however, in CLJC files, which is what I was talking about, what language to rule them all. So that means I can actually I can even write tests for this code that run on the JVM, even though I'm using it on the JavaScript side. Or if I write tests in CLJC files, they will run in both. So I know that my code will work in both environments all the time. At the moment, this approach might not scale eventually, because if it's too many, then you have to do something else. You have to pre-compute some stuff on the back end maybe, but so far it's working well enough. All right, I think that's all with this stuff. So now I put them all back, and then you can see. This is just random data, by the way. It's just like I seeded some random data. It's not real. All right, last thing I wanted to say, because I think is quite interesting, is this library here, as you can see, it's called Vega Bigalight, and it's kind of a language for graphs and interactive graphs. And I can open in Vega editor here, and something here that you can then edit yourself and play around and see how you can make this graph different. For example, I can change this domain, and then I run, and then it will update this stuff. I can change all the styling, and then all my application is doing is basically taking all the information I already have, and then have it dump it into a JSON file, and then pass it to this external thing. However, the thing is that with reagent and reframe and reactive and all these things, you're not, these sort of JavaScript libraries are supposed to kind of be quite side effective. They write on a specific thing on the DOM. So I mean, in short, you just have to write some code to make it happy. And that's quite simple. That's how you do it, for example. So you just have to write this thing called reagent create class, and then pass the function that you need to do the update. So the update here will eventually extract the history and the domain, and then transform that from Clojure data structure to JS. So you kind of write it to JSON and pass it there. So that's all I have to do to actually make sure that whenever something changes, the graph gets re-rendered. And the graph at the moment gets re-rendered by simply kind of repassing the whole thing every time. So it's kind of super smart, but that's kind of the simplest ways to do it. I think that's all I wanted to say. Yes, it says 3 minutes here. That includes questions or not? But yeah, so just conclude, sorry. Frontend is actually really fun with Clojure and CLOJURESCRIPT. Yes, one last thing I didn't show is the way you reload something automatically. So if I now go for a view file, which is impossible to see because suppose I comment out something. I don't want to see the player stats, and I want to see the rankings table. I save, and by the time it reloads automatically, and then it's gone. So there were stats here, and it's gone. So if I change the same way, if I just I can't find CSS, CLJ. If I go to CSS, CLJ, and then simply disable all the CSS for this page, almost all the CSS, and then here it's like this. There is still some like bootstrap stuff, but here it changed all the rendering. So you don't even have to wait for anything. Everything will be automatically on the fly, and that works also for Clojure. For the backend, you just reload and it works. So to conclude, yes, it's actually quite fun to do frontend again, and I encourage everyone to have a look if you haven't already. That's it. Thanks.
Thank you so much. The questions? Anyone? Okay.
So is this some internal like project you made for fun mostly?
Yes, it's a project which is on this link, and this. I've done it with colleagues in a way. Well, I've done it all myself, but yes, it's. I use it with colleagues, let's say. So we just record all the games there, and then we see who's winning, and that's kind of banter.
Do you know anyone who maybe had a more serious production experience with the stack?
With this stack,
Yeah.
I bet a lot of people. I mean,
it's mature already, right?
Yeah. A lot of people are using it. I think there should be a page maybe. Frame users. It's been there for how long? 5-6 years, something like this. There are a lot of also big companies that are using it for bigger things. Reframe. I don't know now exactly. I can't tell you some names at the moment, but so there were. Yeah, I don't know, but there are a lot of people using it. Yeah, that it's actually there were a lot. At some point, there were a lot of frameworks, and then there was some divisions about what to use. I think more or less everyone now is actually going to Reframe, because Home and Home Next are not didn't go so much successfully.
Anyone else? Okay, I have a couple of questions. We still have, I think, 1 minute left.
Yep.
So let's discuss this wonderful technology. I see that you are really enthusiastic about it. So, but being a senior programmer, I think you need to worry about a couple of other things. First of all, the holy grail of the whole programming is whether your code is reusable and composable.
Yep.
Everyone knows that this Alan Parsons architecture has code spread all over a couple of multiple files, and even in Clojure we have even worse situation because we have co-effects which are spread all over multiple places. So how do you write a composable component which is, I think, self-contained, and when you can reuse it somehow, you know?
By component, so you mean like a component which knows how to take the data from outside and how to, well, I mean, there are a lot of ways to solve this issue in a way, and people have trying to do that. I think what I'm doing, I don't know if that helps, but what I'm trying to do is that I actually move as much as the logic outside of here, of the actual framework, and then they are just pure functions. For example, here, this is one of the, this is how you define a subscription, right? So I mean, this thing means this depends on another subscription, but at the moment, instead of actually writing the code here, I just call another function, and this function is in this CLJC file, and then it's simply a pure function that takes some data and returns some other data. So if you do things like this, in general, all you're just kind of composing functions and pure things. You don't have to worry. If you're talking about how to make the actual component in terms of like in the view, to make them self-contained, well, I don't know. I mean, we tried actually at my company also to do like an internal kind of framework to do that. And I'm not convinced it makes it so much of a problem, to be honest. I think it's causing more troubles than actually anything else. But if you can like point me to something specific, maybe I can.
No, that's the question I think that everyone in community is worried about. The second question, and probably the last one, is how to do the code in CLOJURESCRIPT maintainable. Because we have dynamic typing, and Clojure specs are not mandatory everywhere, so especially difficulties we have in macros and so on. So probably this code will be a little bit difficult to read like a year after you wrote it.
Could be. I think depends on, I think actually, well, first of all, CLOJURESCRIPT now it's getting quite smart, and the CLOJURESCRIPT compiler is even able to tell you if you have some type issues. So it can tell you if you try to do +1 as a string, it will fail, and then you can. And we made all these things error, which are warnings. So there is some sort of help there. And then, well, I think it's up to you really. If you do use spec, you get everything spec. I didn't have problems with spec in Clojure. We use it both for the backend and frontend. We use it like between the contract between the two things. And I don't know, it always worked. And then it's actually the error message that we got much better with some other libraries. The errors in general are improving. So I mean, I come from other things that are even worse. So I don't feel so much the pain in a way. And I think Clojure code in general is very readable. Like whenever I look at some other projects, I can always understand what's going on. But that's